Okay, good. Thanks for that, Leo. Good evening, everybody. As Leo said, we keep this. There's nothing complicated with this. It's not scientific, etc. You don't need, dictionaries and calculators. Just a simple a talk, a topic on one of the probably the prominent accident investigation techniques, and no doubt that I'm not under the assumption that most of yours or fellow safety practitioners should know this process as well as others. So to start with, investigations as a safety practitioner, we're all involved in some form of investigation following a incident on site. These can range from simple minor cuts and abrasions, contact dermatitis, irritations, etc. And then they get to the more complicated one where you'll see multiple events, root cause analysis has to be identified, cause and effects, etc., etc. So there's a lot of processes that underpin and set the foundations for us as safety practitioners to follow a systematic sequence of events to ensure that we all are able to carry out and conduct a thorough investigation with the ultimate aim of implementing both initial corrective and preventive actions and learning from the mistakes that have been made, whether it's constructions, manufacturing, aviations, etc. So investigations, as it says up there in the workplace, is a key essential part of any health and safety management system. Undertaking these investigations, that result in injury, death, damage, disease, dangerous occurrences, near misses, must be done in a systematic and organized ways. This will not only benefit the organizations when you come to the end of your investigations and you have to compile robust, good quality health and safety investigation report, analyzing of accurate information about previous accidents and lessons learned and near misses. These are all tools and valuable assets to any health and safety for accident incident prevention from repeating themselves and reoccurring. So it's not something that we should take lightly. I've seen and witnessed many investigations that were flawed, complicated, didn't reach the objective that it was designed to achieve. So I'm going to go through some really basic foundations first before we hit the main topics. Just a couple of slides. Accident process. Let's click on that one there. Okay, first of all, immediate actions. We know what the immediate actions, and that is first aid. First aid, make sure that the first aid is there, make sure that the site is safe. Okay, that should be the safe, make sure the safe site's first. First aid treatment, secure the site. And then once it's secured and the injured person, the IP, is being treated, welfare, well-being considered, whether he's gone to the site clinic, the hospital, etc. But he's safe. Planning the investigation is key. You need to make sure who you're going to involve in the investigation. You might need key experts, scaffold inspection if it's a scaffolding collapse, chemist if it's contract dermatitis or sensitization, etc. So make sure that we've got the key players. Your investigation team is formalized and there is a lead investigator that can coordinate and organize the investigation process. Next quick step is collect information. Most construction sites nowadays have CCTV, witnesses that you're going to need, pictures, photographs, any evidence that you're going to need to proceed with your thorough investigation. Because from experience, that information can quickly disappear because align with construction site. They want to progress with the construction as quick as possible. So a lot of your information will quickly disappear. So you need to get in there quick. You need to get your team in there and gather as much information as you can. Once you've done that, you're probably going to end up with loads of information, sort of pictures, sketches, witness statements, drawings, etc., technical information, procedures, risk assessments, etc. You know what I mean. I said a lot of information, and that information needs to be organized. Normally, you align your information that you've gathered once you become familiar with the sequence of events that led to that incident. Next step, quickly analyze all the information, see which ones are relevant, see which ones are significant to the incident, which ones are contributing factors, underlining factors, etc. You might want to look at your procedures, your policies, your risk assessments, method statement, SOPs, etc. Then once you've done all that, you should be in a position to start, you should be in a position to really identify both the immediate cause, root cause, and underlying cause. And we often don't go deep enough in our investigation, depending on what process you follow, to identify systemic problems, things like culture, management, senior commitment, objectives, etc. So make sure that you've gathered as much information about not only the root cause, but any systemic failure that may have contributed to the sequence, to the incident occurring. And then you report outcome. And I always say this to fellow colleagues, you're not sitting an exam, okay? You're not writing for yourself, write for the reader. So really explain to them in layman terms, sequence of events, causes, etc., failure modes. Make sure that you do a nice detailed report. Don't rush it. A lot of companies have one-page initial incident report and final initial report. You can annex that with a nice final report, dress it up, make it, give the reader something nice to read, because you'll have to justify any recommendations that you've made during your investigation process to the committee, CEO, board, senior management, etc. So make sure that your report is thorough enough, and base your report on factual evidence, not anecdotal evidence, hearsay, assumptions, etc. You can leave that into the conclusion bit of your report. So that's a quick overview, and I'm aware that we had a really good talk maybe a month ago on accident investigation processes. So that was just a quick reminder. Better understanding some of the benefits of investigations, and these aren't, this is not limited to what I put up here. I'm sure that we can all appreciate and understand there are huge benefits for undertaking accident investigations following incidents. So a better understanding of the risks, provisions, any information for use in risk assessments. Obviously, I hate using that word, but you know, when you have an accident or incident, one of the key things, documents that you will need to look at and probably revise and amend based on your findings and your recommendations is your risk assessments, your method statements, specific health and safety procedures, etc. So prevents accidents and incidents from occurring in the future if the lessons learned are realized and implemented on site. So you're going to need to have to review any recommendations at regular interviews to make sure that they're being implemented on site, but most importantly, people are adhering to any of the recommendations that you've highlighted during your investigations to prevent reoccurrence. Power vehicle for motivating the people within your organizing. You know, it shows a caring culture of the organizations that it's going to invest time and money ensuring that investigation is carried out thoroughly and that senior management are involved. If accidents and incidents are occurring on your site, at an alarming level and your staff aren't seeing the results or seeing changes in the organisation structure as a result of your investigations, it's not going to be very motivating for them. Means of understanding, obtaining information on the management systems. You generally learn a lot from accident investigation because one of the key attributes that health and safety practitioners, not just excluding investigators, but we do have an inquisitive mind. We're always digging deeper to find out, well, why did that happen? Why did he make that decision there? What did he go and do that for? Surely that was stupid. So we do have this little trick up our sleeve that we do have. I'm trying to think of a different phrase, but inquisitive mind will sit. Provide evidence of any discrepancies, any failures from what was safe that was no longer safe in the working environment, and what happened. Why did people break these rules when there's clear policies, procedures, instructions, campaigns, drills, etc. And as I said, I'm sure there are other benefits that we could come up with. So, excuse me. Incident. What is an incident? Incidents can both positive and negative. They can turn out to be a good thing or something that's untoward, that has, as said, resulted in some form of loss. So all accidents definitely come under the banner of an instance. Near misses, dangerous occurrences, occupational diseases, ill health, and property damage. So therefore, the quote that I've often said and used is, therefore, all accidents are incidents, but not all incidents end up being an accident, such as a near miss. And if we look at the definition, one of the definitions of an accident, we can see an accident, get tangled up in cable, is any unplanned event that results in injury or ill health, or people, or damage to property, plant, material, or the environment, or a loss of businesses. So something has to happen that has created harm in some way, shape, or form. By virtue of the definition of it's an accident, that means during your investigation process, you must remain non-biased and focus on no blame culture during your investigation process. There is new document, and I read it the other day. How can an accident be unplanned if the person didn't do what he was supposed to be doing, or he didn't follow the procedures, or the organization didn't resource adequately for plant equipment, safety devices, PPE, etc. A near miss, by virtue, is an instance that can be defined as any event which under slightly circumstances may have resulted in injury deal. But basically you were lucky. You nearly got hurt there. That was a close call. And on that note, I know that in the rail industry, they've gone away from the phrase near miss and refer to them as close calls now, such as if you was nearly hit by a train or an on-track plant or equipment, etc. Close call has a better meaning, a better understanding. People are more familiar with the term, well, you were close. You nearly had an incident there. And from accident investigator, I would rather investigate 100 near misses compared to somebody being injured. You know, if we can put the effort and the time in investigating all near misses equally as though somebody's just lost their eye, finger, truck's hit, an object, etc., then if we can thoroughly investigate the near miss, come up with concise, robust recommendations, then hopefully we should be in a position to encourage and prevent an accident from occurring. So that's probably a good definition of the near miss and an accident. A dangerous occurrence, some people still get confused. If you're familiar with REDOR, then in the schedules to the document, there are definitions that explain what an accident is, near miss, medical accident, disease, etc. And it's also industry specific as well. So dangerous occurrences can be defined as any incident, high potential to cause death, such as lifting equipment failure, toppling over, pressure systems, any collapse, overturning, instead of any failure of load-bearing part of the lifting equipment other than the lifting accessory itself, any failure of any closed vessel or associated pipework, any plant or equipment coming into contact with overhead lines, and obviously collapse, including buckling of any overtime. Fire resulting in the stoppage of work, suspension of normal working hours exceeding 24 hours. As I said, these definitions are contained more in detail in RIDDOR regulations, UK regulations. Where are we? Okay, some of the investigation techniques that is often used is one of the most common ones that we are all familiar is the 5 whys, and it is one of the simplest of the accident investigation techniques that is commonly used. And it's like a child, you know, they're always asking, Dad, why do I have to do this? Why can I do this? And the assumption is that if you get to the 5th one, you should be in a pretty good position to identify the root cause to that incident. So a typical example here that I'll give you, a nice easy one, is my car will not start in the morning. Okay, well, why is that? Because the battery's dead. Damn, okay, right. Why is my battery dead? Well, the alternator's not functioning. Okay, that's not functioning, right? Okay, the alternator belt is broken. Well, why was that? Alternator belt was well beyond its useful service and has never been replaced. So now therefore I need to make sure that I get my car service at regular interviews to ensure that my battery remains in good life and it starts as and when should be. Okay. Next one. Okay, the other investigation techniques that can be used is failure mode, and you might sign that with hazard operable studies, where you have a process in place, and it might be something as simple as scaffold erection, excavation works, drainage works, etc. So you design your method, you write your method statement, your procedures, and then you're going through your method of work, the process, to identify where failures are likely to occur. Where's a possibility that something could go wrong? And if that was to go wrong, what impact would that have on the process or anybody involved in that process? So that's a very, very nice, easy process to follow, because as you said, well, what if this happened? What if this happens? Although as safety practitioners, we don't like the word if. We use probability rather than possibilities, but that's a good technical technique to use as to identify where you've got something or you think something, a process is as good as it gets, but then you're just questioning the validity of that and identifying, as I said, where could a mistake be made? And if there was a mistake, what would that consequence be? So it allows you, particularly with document review, procedures, risk assessment, etc. Okay. The other one is event cause. Now, one of the problems with the 5 whys, it asks you why the event happened, but it doesn't define what the event was in the first stage. So it misses that sort of steps. 5 whys, you're dealing with the event, you know about the event, and then you're doing your basic root cause analysis, why, etc., etc. Event cause focuses primarily on the events leading to the incidents, where you've got all your information, you're putting them all in chronological order, and you're looking at a sequence of events. Okay, he arrived at work, he went and had a cup of coffee, he put on his PPE, he asked the driver to take him, the driver, blah, blah, etc. But it also allows on, you know, this is where the whys comes in, assumptions. And once you can prove that those assumptions were realized or not, then you can either dismiss them or add them into the cause of the event. So over time, you'll get a nice chronological order of sequence events that had a trigger, a beginning, and an end. And once you get to the end of understanding how that incident occurred, what were the factors that contributed to any particular failure, deviation from procedures, risk assessments, etc., then you've got a nice event and cause factor chart. Fault tree analysis. If you, I'm sure you are familiar with Bhopal incident in Bhopal in India. This was the method that they use, and this method was, the investigation was assisted by, oh, I can't remember his name now, it's 20 years ago, by UK accident investigation. And when we had his lecture, this was the method that they used to investigate the Bhopal incident. And once again, it's nothing complicated or scientific. It starts with the top, the event, the incident, and then you have this incident occurred because of A or B, and then you can drill down a little bit further. Okay, this incident occurred, this part of the incident occurred because of this and this. It might be because of the weather and poor competency. And it just allows you to keep drilling down until you're satisfied that any additional material that you want to gather is really irrelevant to the investigations and the root cause, and obviously any recommendations. And that's quite common when you're doing investigations. It's so easy to digress into areas of insignificant. He didn't turn up for work because he was ill. Because he was ill, he missed the training sessions. Do you really need to go into detail while he was ill? Probably out all night, or something dodgy to eat. But there's a limit with how far you need to go with your investigations. The more complex they are, the bigger the root trees, and it's not unusual to have a root cause that can span 2 meters on a wall, etc. Postage stamps, etc. So they're 2 or 3 of the most common ones: cause, event trees, fault analysis, and the 5 ways. But the one that we're going to just go over and review is the fishbone diagram. Okay, and it was developed by Ishikawa. Can't even pronounce it now. Ishikawa diagram developed in 1941 and is referred to as cause and effect diagram. It comes from a quality background, lean constructions, originally used, as it says, for quality management systems, but then later it was found that it was very successful and a good way to invest health and safety in environmental accidents or incidents. First used in 1942 in steelworks, has complex set of factors that could be related to help understand a problem. And the reasons why it's called a fishbone diagram, because it looks like a fish, basically. It gets it, as you said, it gets its name because it resembles the skeleton of a fish, and it's what's the words there? Very effective and efficient way of identifying all the probable causes to a particular instance graphically. We can have our mindset of, well, look, we all think this has happened. Well, let's put our thoughts down onto paper. And this does that very well. As you said, it's a nice, easy tool to use because all your brainstorming is recorded. You can see it on the wall. You can add bits to it, etc. Fishbone offers several benefits in accident investigations. As I just said, it allows the investigation team to have a structured approach to accident investigations, cause and effects, root cause analysis. It involves cross-functional teams because at the planning stage of your accident investigations, you're going to get some other colleagues that are coming that are expert in that area of where the incident happened. As I said, chemists, structural engineers, electrical engineers, scaffold inspections, traffic management supervisors, etc. So it involves, not just HSC sitting at a meeting trying to work out and guess their way through an accident investigation. Uncovers the root cause because it does allow you to build on information that you've already gathered, such as the primary causes, subsidiary causes, root cause, systemic causes as well. It's a teamwork effort, no doubt collaboration effort between not only the team, but any external parties that you may, experts' advice that you may need to call upon. Facilitates knowledge sharing among the investigations team. No doubt, as you said, we don't go in there as experts in every field, but you do gain a lot of knowledge, particularly when you're doing corrosion tests, metallic tests, etc., structural tests, crane failures, etc. So, we're there to investigate why something went wrong and there was some form of damage, disease, or somebody got harmed. But there is, you do come out there learning a lot more to make you better investigations. So that's the diagram. That's what it looks like. A fish. It has a tail, heads, and spines. What we're really interested in is in the spines and the head of well, mainly the spines. If you look at this diagram here, this is a particular layer, and it doesn't take long to draw this on a board. To start the process of brainstorming and adding some of the primary categories to your incidents. And Australian, New Zealand guys said, "Oh, we use PIPO." PIPO, okay, well, people involved, procedures you may want to look at, equipment, environment, and the organizations. So that's one set of acronyms that you could use. There are others. You've got the 5 M's and the 5 S's, which if you go onto any YouTube, they probably use the 5 M's. Manpower, mind power, machine, material, method, measurements. All the 5 S's, surroundings, supplies, system, skill, or safety. It's whatever fits your purpose, really, what set of 5 P's, M's you want to use, indicative of the type of accident that you're looking for. Me personally, I think the P's fit better when you're dealing with accidents in health and safety and environmental accidents. Maybe the S is more suitable for quality process failures, etc. So let's have a little look at what this fish looks like. Okay, oh, we've got missed one there. Sorry, let me go back. As you see, the main bones there branching off from the spine represent categories. The primary causes where you want to dig down a little bit further. And as I said, it allows you to keep focus on what areas or what disciplines you need to focus on. The head of the fish will always be the incident, as it's collapse scaffolding, pinch punch industry, slip trip, falls from heights, confined space, etc. Don't need to go into great details because you've already established the outcome of the failure and then the reasons for the incident. So not the reasons, but the incident itself. And that's where you start there. If you look at this graph, you'll see we can go a little bit deeper and start looking at some of the sub clauses here, the underlining categories, some of the categories, and these are lined along the other smaller type branches. So now you can see that you're starting to develop some of the primary causes to failure and some of the categories, and you can keep delving down and down and down and until, as I said, once you're happy that you've reached a level where you can write a report with a good conclusion. This incident occurred as a failure of blah blah A, B, C, D, E, F, G, and then you can start looking at your recommendations to prevent further incidents. So the example that I would like to use is this little example here. Work on a construction site, fell from a scaffold and suffered severe injuries, included fractures and a head trauma. The incident occurred during the installation of roof panels on a two-story building. The worker was taken to hospital and the incident was reported to the HSE. The fishbone diagram is just a mock-up, okay? And I'm sure some of you are going to say, well, we could include this, we could include, which is I fully accept. So this is just to outline the method of doing your fishbone diagram. So the first thing is you need to draw your fish. And I've done one of these on the way to the incident. Sitting in the car with my friends driving. You know, if you've got a notepad, you don't have to wait till you get to the office or somebody's allocated you an investigation room to draw this. It's a brainstorming exercise. So you can write this, and when you get to your incident scene and somebody's laid on a nice room for you, then you can start mapping it. And this is where you get the information and support from other investigator team members. So gather information, draw your fishbone and place the incident itself at the head of the fish. Form the team, as I said, gather individuals from various departments, knowledge about the incident included, as I said earlier on, but not limited to, maybe you're an electrical engineer, mechanical structure, a scaffolding inspector, a chemical engineer, as I said, or any other individual that could contribute to the investigation process and identifying all or any of the failures. So make sure that you've got a good investigation team. Your policy, your investigation reporting policy should define your investigation process, who's going to lead the process, if it's a major, minor, sorry, if it's a major, minor incident, etc. Sometimes they may be carried out internally, or you may need somebody to chair it from a different department, or you may need to employ a consultant to assist in the process. But as I said earlier on, it is a teamwork exercise. An individual on his own cannot do a thorough investigation. Too much work, too much running around, too much gathering information. Okay. Clearly define the problem at the head of the fish. These are some examples. Again, hit by a semi-truck, slip, trip, burns from welding activity, etc. Entrapment formed from robot. So once you've done that, you start drawing your little fish. I'll just put a picture of the incident there rather than the description of it. And so we can whack up, okay, we want to look at the people that are involved in this incident. And I'm following the PIPO principle here. So we're going to look at equipment. We want to look at environment. We want to look at processes, and we want to look at the organization as a whole. And we want to look at the emergency response procedure because it was a fall from heights. We want to see how that worked. And did his injuries exacerbate during the emergency response? It's not unusual. I'm not carte blanching every company here, but it's not unusual to put the poor guy in the back of a pickup and run him to hospital, and then you find out that the injuries were caused by the transportation, back injuries, etc. So these are some of your major categories that you want to sort of start looking at, and you wouldn't be that far off if that accident happened somewhere in here. Your underlying causes, your root causes, your systemic failures are somewhere hidden in here, and it's up to you as investigators to start drawing that out. Dig a little bit deeper. Okay, so we got people, and we want to look at the workers, the trainers. We want to see if there's any witnesses. We've got the witnesses from the gathering information. We know where the witnesses were standing. We've got the names, and we know how they were involved in this instance, or were they just observers? Okay, supervision. what supervision was in place. This is a scaffolding fall from heights. What supervision was in place to supervise that everybody was using the scaffold correctly, access and egress was in place, the scaffold itself was erected in line with the method statements, operation procedures, the design criteria, etc. We want to look at the equipment, the scaffold system. It's safe. It's safe. What type it was, cut block, tubular, etc. PPE. If he's fall from height, how did he fall? Was he overreaching? Were the guardrails missing, etc.? Was it green, yellow tag, etc.? So, was there a requirement that under certain conditions of the scaffold system, PPE was required? If he was told by a supervisor, was the training covered enough? Maintenance and inspections, we should know that there are regular inspections every 7 days, thorough inspections, visual inspections prior to use, and obviously re-inspected after any inclement weather, wind, rain, etc. And we want to look at the roof panels itself. He fell because he was trying to put some roof panels onto the roof. So what was the weight of these panels? We want to look at the environment, the weather. Was it windy? How big these panels were they subject to wind shear, the loading on the scaffolding, etc. Noise issues, space issues, and ground condition of the scaffolding itself. So we're starting to dig down now under these primary causes to get down to some of the subsidiary causes. Procedures in place. Health and safety inductions, was that clear? Was that concise? Did it cover, PPE requirements? Did it cover work at height requirements? Risk assessments and RAMs, were they specific to that particular tasks? Well, were they just cut and paste documents? Being cynical now, just to get approval. So were the risk assessments and the method statements aligned with the scope of work? Did they cover all the hazards? Did they address all the risks? And did the control measures that arises from your RAMs, were they implemented during the inductions, pre-start briefings, supervisor briefings, etc.? Work at height requirements, procedures we're looking at here. Does the company have a work at height procedure that outlines the requirements for working on any mobile platform or scaffold system? Audits, were there any audits that had identified previous problems, issues, concerns, weakness regarding work at height activities? Organizations arrangements, and we're looking at overall supervisions. We're looking at shift durations of the worker, 8 hours, 10 hours, double shifts, rotations, etc. Health and safety culture of the organizations itself. Did it have a care and considerate attitude to its employees regarding health and safety? Was there clear, visible commitment from senior management, or was there just a can-do attitude and we'll go through and it's got to get done? Okay, and then lessons learned. I said, were there any previous accidents or previous incidents surrounding scaffold work on this particular site or environment? And then emergency response. We want to look at the provisions of third aid. Were they adequate? Were they efficient? Were they carried out in a timely manner? Or did the injuries that he sustained exacerbate due to poor first aid, emergency response on recovery? Hospitalizations, the location of the hospital. How did he get to hospital? Is he still in hospital? Is he out? What sort of treatment did he see? And no doubt, one of the key things cynical, the client will want to know is his medical condition. It's the first thing they ask. Oh, what's his medical condition? Which is quite rightly saying, is he okay? Is he going to be all right? When is he going to be back to work? Is this going to affect our LTI? I didn't say that, by the way. Okay, so we need to make sure that somebody as part of the team is allocated to look at that area of the investigations. And sometimes medical records aren't always forthcoming. They won't release them without consent of the IP, and the IP's unable to speak or move because he's crutches or wrapped up, etc. So this is where you start to dig down a little bit deeper, and all of these areas do require further investigation to see if any of these factors contributed to the overall the overall incidence itself. And if you look at training, one of the areas you might want to look at, or you could look at further, is the trainer himself. You know, is he a qualified, approved trainer? Does he know his stuff? Is he competent enough to give training on worker height, scaffold, mobile house, excavations, etc.? The training package, was it robust enough? Was it clear enough? Or was it just a couple of slides, get somebody in, out the door, tick in the box, done? So these are some of the areas that you may want to look at, just focusing on training at the moment. And attendance, you know, did the guy attend the training package? If he didn't attend, was he put on another training course, or was he allowed to work on a scaffolding subject that he will turn up and do the training of the following day? So as you see, there's probably about 21 underlining factors there that could have contributed to this incident, as I said, connected with the primary cause. At some stage, you need to filter that out. And very good. Okay, thank you. At some stage, you need to filter that out, because if you apply, and I don't want to digress here, Pareto chart or principle, 80%, 80, 20%, you will probably find that only 20% of these causes actually contributed to 80% of the accidents. And as I said, you don't want to waste a lot of time looking at procedures and policies, etc., because generally they're at the lower level of causation of accidents and incidents. You know, there are more important things and priority things that we should be looking at. So I'm not saying that you have to start designing Pareto charts, but there are methods, particularly if you've got a good team of accident investigations. And there are methods where you can like give everybody, okay, guys, around the table, you've all got 9 points. I want you to put 5 points where you think the primary causes or the important cause is, 3 for secondary and 1 for minor, and then you end up with obviously some results, and you can table those results quite easily into a simple little chart like this. And if you're applying the 80% principle, which I did as a demo here, you can see that the red line stops at workers, maintenance and inspection, supervisor, training. So what the team is telling you is that this is where we need to focus more thoroughly. We need to focus on the workers' attitude, culture, language barriers, etc. You know, why did he do any induction training that he had? Was he familiar with induction? Did he understand the health and safety inductions or the worker height training? Was there a test at the end of it that evaluated his training or provide some form of qualified retention? So these are the primary areas that you really want to sort of look at. And as I said, we want to look at the workers, we want to look at the maintenance, inspections, supervisions, training. And then we can go down and maybe look at the other items as well that we put on the cause and effects diagram. But, you know, don't get too hung up investigating this. If you're pretty sure this is how this accident happened, the guardrail was removed, blah, 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 etc. Why was it removed? So that's how I would prioritize my probably causes of this incident. But again, these are root causes, not the underlying causes, because you will want to dig a bit deeper. But if you notice, we haven't applied the 5 whys yet. And this is where you generally find that the 5 whys principles you can combine with other investigation techniques or processes. And what we can then start doing is we can have, once we've identified the primary causes, as I repeat, workers, trainers, maintenance, supervisions, focus on that. We can have a look at some of the sub clauses, RAMs, etc., first aid, later on. But once we've identified some of the primary causes, the ones that are clear that contributed to this individual falling from a scaffolding, then we can start looking at our root cause and asking the 5 whys. And one of the quick, easy, nice methods here, and once again, you're probably familiar with this, is root cause analysis. You start at the top again with the event, and you're asking questions, right? Okay, scaffold system, removed guardrail, not installed. And you just keep drilling yourself down, and/or gates, training, not available, did not attend, was not informed, was informed but did not turn up, day off during the training. Okay, was there a refresher training? Maintenance and inspection to the right, daily inspections carried out, daily inspections not carried out. Okay, inspector not competent, inspections not thorough, daily inspections not carried out, procedures not in place, construction risk profile not carried out, risk hazard analysis not carried out. And you can keep digging down, drilling down until you get a point to you think, okay, I've got enough information now to make a substantial and accurate conclusion of how, when, why, and where this accident happened, and what recommendations are going to be robust enough and consistent enough to prevent a reoccurrence of this incident. And this is where these simple tools, simple graphical calls can be, charts, diagrams can be used just to make sure that your mindset remains focused. And as you said, if this is on a board in your investigation control room, etc., you can add to it as and when. You might think of different, okay, well, look, we need to look at the culture of these organizations. Is there a commitment from senior management, accident preventions? Is there a budget for personal protective equipment? Are they trained in its use? Are there campaigns? So you can dig down as far as you really like, but just be cautious that there is an end point to an investigation. So strengths. Helps to find a consider all possible causes of the problem rather than just one that are most obvious. Stay away from assumptions. I said earlier on, you're looking for objective evidence here. Stay away from anecdotal evidence. Well, I believe this happened, or it looks like this happens. No, if you can't prove it beyond reason, if you can't prove it enough without, I've forgotten the phrase now, without being accurate, then don't use it in your findings of your investigations, other than in the conclusion discussion session. Helps to determine the root cause of problem, quality characteristics in a structured way. I think that's the main thing, because, a fish diagram, we've all seen fish, we've all seen skeletons of a fish. It's nice, easy to position, the causes, the root causes, the sub causes, etc. Nice layout, easy to understand. You can add to it as you want. You can delete stuff from it if you don't feel it's significant or relevant to the investigation process. Encourages group participations, and as I said earlier on, knowledge sharing is valuable. And I do maintain that if you're a safety practitioner and you're asked to investigation, then you need to go and clarify, okay, I'm happy to take on this investigation as per our policy, as per our procedures, as per best practice. I need to plan these investigations, and I need additional support from key individuals that are going to assist with the investigation process. Helps to focus on the cause of the issues without resorting to complaints and irrelevant discussions. You do get individuals that are biased. Oh no, this must have happened because of this. Having a team approach, it does eradicate that. using the Pareto principle also brings it back down to a format. You're not going to dismiss anybody's input information, but it needs to be relevant, and as you said, as part of the investigation process. So it helps just fine tune the mindset of individuals around the table, or those that are involved in the investigation itself. And it does create a lot of discussion. Oh, I think it was this. Okay, it could have been this. Okay, well, let's have a little look at this side. Let's have a look at the failure mode process of this. Well, actually, it was fine. So strengths, as I said, use an orderly, very easy format in a diagram to make the relationship between the effect, the incidents, and the causes that contributed, that led to that incident happening. And then, as I said, you probably want to apply, once you've done that fish diagram and you've got all the information you need, then you can start doing root cause analysis and asking, whys, etc. Okay, weaknesses. Increase knowledge of process by helping everybody learn more about the factors at work and how they relate. And look at you're looking at processes here. Even if you deviate from quality process, input output process, erecting a scaffolding is a process in itself. Digging a 3-meter trench is a process in its place. It relies on people, the environment, the PIPO headings. All these factors are relevant to your investigation. Identifies areas for further study where is a lack of sufficient information. The bolt that was holding the crane down, the gantry cranes broke. Okay, well, we need to go and get that metallic tested, etc. It's giving you better information that you didn't know. You might need to go to the factory or the lab where it was tested, etc. So you do come away learning more stuff out of investigations. Having said that, it's not a school trip. Limitations. Okay, not particularly useful for extreme complex problems where many causes and problems are interrelated. For this, you're better off using Taproot, which considers human factors. Its systemic behavior is embedded as well, and that's where complex, multiple events happening at the same time all contributed to one incident. So you probably want a more detailed, thorough process. And I said Taproot or Kelvin Topset are commonly used for that process. Okay. Prioritize of cause when the diagram can be subjective. And as I said, you're looking at objective evidence gathering. So make sure that your team is focused on that aspect of the report, the investigation process. You don't want to be influenced by individual bias, assumptions, anecdotal evidence. It is a step-by-step process. No blame culture. Do your job, gather as much information as you can, prove points, prove causes. You keep going. One person said to me, is there a time bound on an accident investigations? Yeah, when I finished. Okay, and I know that we get request from senior management. Oh, can we have an update? Or we need the initial report within 24 hours. Okay, fine. Initial report, incident occurred. We're in the process of doing investigation. The IP received first aid treatment. He's hospital. He stayed in over 24 hours. He suffered a minor fracture to his wrist. The investigation is ongoing. The investigation team is ABC. The investigation process that we will be using will be the fishbone diagram incident process. And that's really it for initial investigations. Don't make stuff up. Don't beef the report up. You can leave that for your final investigation. Time bound, as I said, if you keep your senior management updated and engaged now and then, where you are with the investigations, at which point have you completed this part of the process, etc. They will leave you alone until you thoroughly complete your investigation. Please do not get pressurized to investigate an incident any quicker than you think it should be done. All you're going to do is end up coming up with ambitious, ambiguous recommendations, tick box exercise, etc. And I've seen investigations where we need to review the logistics plan. Well, that's got nothing to do with these investigations. Why are you coming up with stuff like that? Well, I just wanted to get the report out of the way. Well, you're going to tell that to the next person that suffers a lost arm, finger, eye in hospital because of cancer, etc. No, we have an obligation. We have a moral obligations. We have a professional code of conduct to follow as a safety practitioner or an accident investigator. So without further ado, thank you very much for your time. As I said, brief overview of cause and effect and how it all fits together. Have a practice with it. Make up a mock accident or incident, or find one that has happened in the past, and just apply these principles and see if you gathered more information following this technique than you did previously. You know, I'm not here to teach you or turn you into accident investigations. As I said, you have that accolade of an inquisitive mind anyway. So just use it in a structured, organized way to enable you to produce something that is of good quality and ultimately prevent the next accident from happening or occurring. Okay, any questions?
I don't see any question in the chat box, Riz. So I guess everyone is happy with the presentation, but I do not know if there's any insight that we can hear from them. Let's give it a few seconds. But otherwise, I believe everyone is happy with the way you presented it. The only thing with this exercise is if accident investigation is not really your forte and it's not being practiced always, chances are you will always have to go back to the basics, right? The good thing is we have professionals like Riz, our speaker, who can guide us, especially in our group here in IIRSM Qatar branch, that can who can assist us in the event that we may need assistance. That's why I'm always encouraging everyone to stay in touch and to be active in our group chat. And you can always communicate with me and I can relay this information to people who can assist us. And we really want to get you engaged because our organization is not only all about presentation every month, but it's all about engaging everyone. In fact, I had been encouraging you to present bite-size to prepare bite-size presentation that may last for 10 minutes maximum, or let's say 15 minutes, so that you can also share to us things that are noteworthy to be learned from. So our next meeting hopefully will be either on November 19th, and I'll be waiting for or 20, but most likely it will be November 19th. I'm waiting for any volunteer. You always know that I'm always ready to step forward to give a presentation. But of course, it will always be good that all of us are engaged because this is our branch, and we always learn from each other. So, is there any
Well, there
insight
was
that?
one. there was one question that came up about risk rating
Yeah.
and the alignment with accident incidents. And good question. Risk rating is part of the risk assessment process, and it comes under really the banner of accident prevention, because as a result of any risk, that's going to prioritize what control measures that you put in place. So your risk assessment is really designed to prevent the accident from occurring in the first place. Accident investigations is reactive. The accident has already happened, so yes, I think a thorough risk assessment, once again, done as a team, is a process for accident incident prevention rather than a means for investigation, if that helps the guest.
Yep. Thank you, Riz. There's also a request for a taproot presentation. So we will see if we can have a volunteer for this, and we will let you know. Also, just to supplement to the question, does risk rating determine if you can use fishbone? The thing is, you need to identify what risk event you can find, so that you're able to establish the proactively, instead of course, we all know that the accident investigation is done after an incident has happened. But proactively, of course, you want to prevent accident from happening. But of course, you can conduct proactive risk assessment and in your risk register if you are managing your risk. So you can establish your risk statement, finding out for the event, what can be the cause of it, and what can be the consequence, and then establishing your likelihood of that incident, particular incident to take place, and its consequence. Of course, how will you mitigate it? But otherwise, that's already out of the talk for tonight. Thank you so much.
Two
Yes, Reese?
seconds, one thing. Just in case I got that question right. If risk rating, if the consequences of an incident failure is going to cause significant damage to your organization, then you can categorize you can design your accident investigation technique more thoroughly, such as when you start looking at disaster recovery and the impact of that investigation that's going to have on your organization's financial loss, reputation, well-being, etc., police involved, then that will dictate what method you use to investigate that incident. So the question you could probably align, which I would alluding to, is that at what level would you use certain techniques for, and that will be based on your disaster recovery and the impact that accident is going to have on your organizations. Little impact, a very simple 5 whys technique. Major impact, you want to be thorough enough. You're looking at taproot, Kelvin, top set, etc. Okay.
All right. So with that, thank you so much, everyone. Thank you, Suzanne, for facilitating tonight's meeting and CPD presentation. So I'm looking forward to having you once again, guys, for the month of November CPD. It would be greatly appreciated if one of you can step forward to give us a talk about risk related to risk and safety, and we will see if we can have someone to talk about taproot analysis. So thank you so much. We will announce in our WhatsApp group the next scheduled meeting. Stay safe, everyone, and be risk-free. God bless. Thank you.
Thank you very much. Bye.
Thank you, everyone.